Welcome back, everybody. Lesson 10A-3. Actually, it's really two sections in our textbook. Volume of rectangular prisms and cylinders. No homework to review for today. So threefold goal, or you could say onefold, because really we're just trying to find volume of different shapes, both rectangular prisms as well as cylinders and composite prisms. We'll talk more about that in a second. So remember what we started off with was one-dimensional. What's length of actually that's a line segment, or you could do length of a curved part, that would be the circumference. Then we went into 2 dimensions. What would the area be of that circle? Or actually we did other 2-dimensional figures, polygons, triangles, etc. Now we're going to get into 3 dimensions. So how many cubes of ice would fit a freezer? How much air would be inside that building? How many cubes of soup would be in that can of pop? Sooner or later, we'll get to surface area of 3D figures and more figures that are composite. For now, whatever the date might be, whatever the assignment might be, go ahead and pause, get a note page ready for your notebook, and come on back when you're ready. The assignment will be a worksheet. I don't know if there's enough space to write all your work on there or not. Many of you prefer to put your work into the notebook anyways. All right, which box would hold the most cubes? Box A, box B, box C. Take 5 seconds to make a prediction. Now, if we look at box A and I pull this up, we notice that there is one layer of 4 by 3. In other words, that's 12 cubes. If I put another layer in, another set of 12, well, I guess that means there would be 24 cubes. Next one. We have one layer of 2 by 2, so that's 4 cubes. Another 4 would make 8. Another 4 would make 12. And another 4 appears to be 16. And box C looks to be wider, perhaps, maybe not. One layer of 4 by 2, so that's 8 cubes there. Another 8 makes 16. Another 8 makes 24. So believe it or not, there are 2 of these shapes that are tied. The point is that volume is measuring not 1, not 2, but 3-dimensional cubes. That's why I think about ice cubes fitting a freezer. So how might you find that? If you notice that was it the first example, last example? 4 by 3 by 2. Volume of a rectangular prism, surely you've already heard this, where the first thing you figured out was how many squares would go across the base of that. In fact, any prism is the area of its base times the height. That's why I use a capital B. It just so happens in this case that the area of the base is a rectangle. And then what you do is you just stack that base higher and higher and higher and higher. That's why you multiply it by that 3rd dimension, the height. So for instance, in this case, the length and the width are 4 and 3, which makes a base area of 12 square units. But then you stack those 12 square units 2 units tall, and 12 by 2, of course, makes 24 cubic units, 24 cubes. And oh, by the way, I could theoretically change that shape and still have the same shape. So what if instead of 4 by 3 by 2, I made it 2 by 3 by 4? Well, 2 by 3 is 6, and 6 by 4 is still 24. After all, as you noticed, I rotated the same figure. So in theory, it does not matter which length, which and height, which dimension you use for the length, width, and height of a rectangular prism. So using that volume formula, again, some of you like the area of the base times the height. Others of you notice for a rectangular prism, at least for today, rectangular prism, we're always going to do length times width times height. 1, 2, 3, 1, 2, 3, 1, 2, 3. So what we have is 3 by 3 by 3, or 27 cubic units. On the next one, we have 1, 2, 3, 4, 5, 6 for a length. We have 1 for a width, and we have 2 for a height. Using the formula of 6 by 1, that would be 6 square unit for the base, and then stack them 2 units tall. Final answer of 12 cubic units. Do this next one on your own. Pause if you need to. Come on back when you're ready. 1, 2, 3, 4. 1, 2, 3. And 1, 2, 3. So we have a base area of 4 by 3 or 12 square units. And then we stack those 3 units tall for a final volume of 36 cubic units. Now, that's showing all the actual cube measurements. What if you don't have it? It's okay. You're still going to measure and use the same formula. So let's take a look at this rectangular prism that is an aquarium. We're still going to multiply length and width and height, where in this case, length I'm seeing as 4, although remember, it doesn't matter which you make the length, width, and height, as long as you use each one appropriately. I'm seeing a 1 foot, so kind of a skinny aquarium, and then we stack it 2 tall for a final volume of 8 cubic feet, not square feet. We don't just want to know how many squares go along that base. And it's not feet. You don't just want to know how much corner protector you put along the edge of an aquarium. You want to know how many cubes of water, I know that sounds weird, but how many cubes of water will fit inside that aquarium. Fiber, same thing here. First write the formula, then the base appears to be 20 by 10, stacking at 30 tall. Now 2 times 1 is 2, times 3 is 6 with 1, 2, 3 zeros. So this will be 6,000 cubic centimeters. And while that sounds huge, remember, we're just talking tiny little cubic centimeters. That's not the best to figure. There we go. Tiny little centimeters, cubic centimeters of cereal. All right, next up, go ahead and pause your video. Come on back after you take care of the building. So I would argue the base is going to be 60 by 30, and then you'll stack it 80 tall. Final answer here, 144,000 cubic feet. And yes, folks, heating and cooling workers have to work this out all the time in order to make sure they have the right equipment to heat a building, to cool a building in the summertime, that sort of thing. So they're measuring volume of air a lot. What if? Actually, you might pause, start the homework, maybe do numbers 1, 2, and 3, and then come on back when you're ready to get into problems like number 6. So pause your video, come on back. All right, what if? What if we have a composite figure? Now think about the word compound in science is a substance that's made up of 2 or more different elements. And if you look carefully at this shape, you could split it apart into 2 different prisms. Now that's not a big deal for the first one, because you'll notice that we have a rectangular prism that is 14 by 14 by 14. But what about this first guy? See, I do see 28. Let me go ahead and write the formula for this guy as well. Let me just pause for a second. And I'm going to note that if you found each individual volume, but you want the entire volume of this shape, what would you do to the sub pieces? What would you do to the parts? And naturally, you wouldn't be surprised to say, well, Mr. Callan, I'm going to find each individual volume and then I'm going to add them together. Great. So the small one was easy because all the measurements were there, 14 by 14 by 14. But that 28, ladies and gents, that's not exactly part of that shape. Now here's what I mean. Let me go ahead and move this guy back. And I'm going to look at the different sub pieces here. I'm going to say if this edge is 14, then so too is this edge. If that edge is 14, then that piece is 14. So what does that leave us over on the left? Well, if one part is 14 and the entire thing is 28, that would leave a base length of 14 for this particular shape. Okay, now we got to do it again because this is 14, which means this is 14, which means this is 14. Now, if you go over to the other left edge, the entirety of that is 21, which means this piece must also be 21. Now, if you have one part that's 14, 14 plus what is going to be 21? Naturally, that makes 7. Actually, I'm not sure that was relevant, but that's okay. Here's the last part. How do I pull this off without making it super ugly? So we already know that 21. That last part really wasn't necessary. Let's look at what we have. We have a base of 14. We have a height of 21. We need this piece. All right, Mr. Callan, come on back. If this is 14, then the last part's got to be 14 as well. Not the best of explanations right now, folks. I apologize. I'm struggling with the visuals. So in this particular subshape, which I would say is kind of the bigger piece, you'll notice that I almost always start with the volume of the big guy, and then I do the volume of the little guy, and then I go ahead and either add or subtract depending on the problem. We have 14 by 14 by 21. We have 14 by 14 by 14, a perfect cube. And if we add those together, we will get a total volume of 6,860 cubic feet. You'll notice even this that I had prepared, for whatever reason, I wrote 21 by 14 by 14, but that's the same shape, even if it's rotated. I guess what I'm asking you to figure out is, first of all, if you have a compound figure and you want to find its volume, find a big shape, a big 3D figure, find a little shape, and then decide, do you need to add or subtract those subshapes? Now, in our case, today almost always we're going to be adding, but there will be times where you'll subtract. There will be times where you might drill a hole through a bead and you don't want that inside part, right? There will be times when you might say, look, we don't need to heat the top floor. That's going to be all an unused equipment space. Okay, so you take apart, you take away that volume. But for the most part, we're going to be looking at adding up today. All right, I'm going to bounce to a couple different problems and ask you to kind of design what kind of box, what dimensions of a box would have a volume of 18. There's several different answers, so go ahead, pause your video and ask, what could I make as a base length, a base width, and a height that would equal 18? I know one's obvious. You could do 1 by 1 by 18, right? So now see if you can come up with some others. Pause your video and come on back when you're ready. So I came up with a number of them. You got 1 by 1 by 18. You got 3 by 3 by 2. 3 times 3 is 9 times 2 is 18. You got 2 by 9 by 1. I wonder if there's any more. Perhaps some of you came up with 6 by 3 by 1. And forgive me if there's others, maybe, maybe not. But if you bring them to class, let me know if you can find something else. What if I gave you 2 of these and found a missing piece? All right, so let's say the volume is 48. What's that missing piece got to be? Well, you can always set up length times width times height. And you can say, wait a second, I don't know what the height is, but I do know the volume, which is 48. And I can substitute in 3 and 4 and 1 missing piece. Now all we have is to use our algebraic skills to say, well, look, we can simplify this mathematical statement and then divide both sides by 12. And if you guessed 4 inches, you would be correct. All right, so at this point, you can work on the front side of the assignment. Pause your video. I would say get through, if you want to do all 12, that's fine, but at least get through the first 9 and then come on back for the rest of the video and we'll get into cylinders. So, as for cylinders, I want you to think about the similarities and the differences of finding volume of prisms versus cylinders. I'm going to make this infinite cloner and just think, remember what we found. To find any volume, you want to find that base, and then you want to keep stacking them and keep stacking them and keep stacking them all the way up. That's where that height comes in. Now, it just so happens that for a rectangular prism, the area of the base is the length times the width times the height. Noticing 3 dimensions here. Well, we're going to do the same thing with a circular prism. That's kind of a weird way of saying it. You wouldn't actually call it a prism. It's got no edges. But if we were to find, look at this, same thing here. If we were to find the area of that base and then start stacking it and stacking it and stacking it all the way to the top, you're still going to have that height. But in this case, the area of the base is not a square. It is not a rectangle. It is, you guessed it, a circle. And so we would find the area of that circle, pi radius squared, times its height. So I want you to pause for a second and just think. You don't have to pause the video, but just think. How are these problems similar? Well, in fact, they both start with the same formula. Find the area of the base and then stack it up, stack it up, stack it up. That's where the height is. They also both have 3 dimensions. On the left, we have length, width, height. On the right, we have radius times another radius, radius squared, times the height. How are they different? Well, on the left, they all have edges. So we're talking length, width, height, but there are no edges on the right figure. Not surprisingly, with a circular piece, pi is going to come into play. We didn't have pi on the other side. So a lot of similarities here. Find the area of the base and then stack it up times the height. And then the major difference for rectangular or square prisms, you're going to do length times width times height. For circular prisms, not really a word that I know of. For a cylinder, the area of the base is pi radius squared, the area of the circle, times the height as you stack those circles up. Now pause, rewind if you need to watch that again. I just want to review. You're going to find the area of that base, which is pi radius squared, because the area of that base is a circle, and then you're going to multiply it by the height. So radius times height naturally means we're still going to be using cubic units, cubic centimeters, cubic inches, cubic yards. Onward we go. Let's take a look at the first example. All right, so I know the pi. What is the radius here? Well, the radius appears to be 3 because it starts in the center, goes to the outside. Height is 5, so pi times 3 times 3 times 5. And I hope I rounded that properly using the pi button because a previous teacher did not use the pi button. Let's take a look at this other one. Now, folks, we have to be wise enough to say, okay, this is a cylinder, but it's tilted or rotated, should I say, on its curved face. So you have to be able to see, okay, wait a second. The height is going to be 7 because that's from one base to the other. Meanwhile, the radius, again, appears to be 6. So pi times 6 squared, yes, you can write 6 squared, you can write 6 times 6. It doesn't matter to me how you write that. And if you multiply pi times 6 squared times 7, you get 791 and 6/800 units. All right, one last problem, picking up the pace here. We're going to take a look at 2 different products and try to figure out which is the best value. Now, I could divide and make a ratio of cost to volume, which kind of makes sense, right? Dollars per cubic inch. But in this case, they both have the same cost. So I'm not even going to make a ratio. I just want to know what is the volume and who's going to give me the most pop for the same cost. All right, so I take a look at this first one, volume, pi, radius squared, height. In this case, the radius appears to be 3. Don't forget to square it. 3 times 3 times a height of 9. Now, if I went ahead and calculated that out, it's going to be 254 and 47 cubic inches. That is an approximate. It's not perfect. It's an approximate. Now let's take a look at the other side. Same formula, pi radius squared height. Height appears to be 12, but wait a second. Look at this. Look at this. Okay, we know that goes from one part of the circle all the way through the center and to the other. That, ladies and gents, is a diameter of 5. Therefore, we're going to have to cut each of that up into 2 parts. So each radius is only 2.5. Beware, beware when you're doing that not to use the diameter. In this case, if I multiply pi times 2.5 times another 2.5 times 12, I get 235. And when I examine those two, I've quickly find, to my surprise, I would have thought the taller one looks bigger, but on the other hand, it's actually the left piece that is the better deal. One thing that I really want you to pull away, how are these problems similar? Cylinders, pi radius squared height. The height was easy to find. How are they different? The most important part from this problem, if they give you the radius, you may immediately use that 3. On the other hand, if they give you the diameter, you have to cut up the diameter to find its radius. You guys should know that by now. All right, with that in mind, go ahead at this time, start the back side of the homework, bring some questions to class. Take care, folks. Do well. Let's grow. See you.